Hey guys, welcome to Unit 1, Lesson 5 Notes on solving radical equations. Remember, a radical symbol looks like that, except neater and better looking, and equations have equal signs in them. That's why they're called, equations. Ha 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 ha, because they have equals. Okay. So before we jump right into solving radical equations, we're going to do a tiny review of solving equations. Now, I'm going to argue that solving an equation is like opening a present, and here's why. So you have this, wow, that's a really ugly present, you guys. It's a nice box, but let's wrap our present. Let's wrap it first, okay? So you get some wrapping paper on your box first. It's green, it's like Christmas green, okay. And then after we wrap it, let's put a nice gold ribbon on it. So we'll put a nice gold ribbon on our box. Okay. Tie it in a bow. That's the bow. Isn't it great? Amazing. We'll give it a little character. Why not? Okay, good. There's our gold ribbon on our present. Wow, guys, that actually looks really good. Okay, so how do we solve, or rather, how do we open a present? Well, our first step is you need to untie the bow, right? And then we need to take off the wrapping paper. So unwrap. And then finally, we need to open the box and see what's inside. So there's an order here. The key idea is that order matters. Order is important. Okay? So we're going to keep order in mind as we solve our steps. Now, that's not even our key idea. Our key idea of the day, or your goal, your objective, is to solve equations containing radicals and also to check for extraneous solutions. We'll talk about that in a little bit. So our key idea is that you can solve equations, not expressions. You can solve radical equations by squaring each side, because the square is going to undo what's happening to your variables. Remember that a square, it's like our gold bow, right? You're going to square each side of the equation. And then after you've squared them, then you want to test. I always test with gray. You want to test the individual solutions. So you can solve radical equations by squaring each side of the equation and then testing the solutions. When we go back and we look at our present real quick, yeah, this is the order of unwrapping a present, but let's look at the order of wrapping a present. Whoa, did I break Notability? No, I didn't. Okay, so this is to unwrap, to open a present. To actually wrap a present. Oops. Good thing this is an English class, I guess. To wrap a present, we can't follow that order. We need to follow a different order. The first thing I need to do is I need to put whatever's in the box and make sure that the box is closed. And then after that, the first thing I do, which I guess the second thing now, is I put on the paper. So I put on wrapping paper. I'll just put wrapping paper. And then finally, I tie a bow. Now you notice that these orders here, we have some undoing going on. We tie the bow as the last step, and we untie the bow as the first step. And then we put on the wrapping paper before that, but we unwrap second. And then finally, you make sure the box is closed as the first thing in wrapping, but it's the last thing you do to undo that, to unwrap the presents. So solving an equation is like unwrapping a present in the sense that you are doing the backwards order. So our order is reversed. Backwards order. And everything that you're doing is undoing. That's very important to keep in mind. Okay, so the first thing we do, we untie the bow, and the last thing was to tie the bow. We unwrap. We unclose the box, we open the box. So it's the backwards order. And that's why when we have a square root, the first thing we're going to do is we're going to square the radical to get rid of it. But I misspoke. It's not going to be the first thing because look what's happening. Let's say we've got an A box, right? Our A box here basically has a radical wrapping paper. Cool. To unwrap that, we need to square it. But first, it's got a golden bow on it. It's got a 5 bow. So the first thing we need to do is we need to undo that -5. And what will undo a -5? We need to add 5. And of course, what you do to one side of the equation, you need to do to the other side of the equation. So here, those will cancel out. We're left with just the square root of A equals -2 plus 5, say +3. I'll show my work in black, I decided. Okay. Now, we have the square root of A equals 3, and that's great. But we want to unwrap this guy. So to unwrap the square root, to unwrap the square root, we're going to do the opposite. We're going to undo it. And how do you undo a square root? Well, you square it. But of course, what you do to one side, you need to do to the other side. So the square root squared just gets rid of that. That clears it all out. We're left with A. And then 3 squared is 9. Cool. Isn't that great? Now let's check. Did we do this right? Does this actually work? So to check that, so we found out, what's in our A box? We have a 9 in the A box. So let's plug it into our original equation. Our original equation said the square root of A minus 5 equals -2. We're going to substitute 9 for A in here, which is nice because A kind of already looks like a 9. So you have the square root of 9 minus 5 equals -2. Well, what's the square root of 9? 3. Minus 5 is -2. Oh, I forgot. We're checking our work. Whenever we check our work, I like to make it gray. And we're checking. So we say, is it true that? Is it true? Is it equal? And yes, it is equal. So good. A does equal 9. It works. Let's do another example. So here we've got 2 boxes, and they're both in wrapping paper. Cool. We've got square root of 7b minus 4 and square root of 5b plus 10. So the first thing we're going to do is we're going to undo this wrapping paper. How do we undo a square root? We square it. So we square both sides. And because the square root and the square, that will cancel out, we're left with just 7b minus 4 equals 5b plus 10. And then it's just like solving any other equation again. We get all our variables to one side. So we'll subtract 5b from both sides. That gives us 2b minus 4 equals nothing. They cancel out. Plus 10. Isn't that so nice? You're like, bye. See you later. And now we want to get rid of this 4. So to undo our -4 bow here, we're going to undo that by adding 4 to both sides. So we have 2b equals 14. And then finally, we've got one other sort of packaging. It's like you've got your present in the plastic packaging and you need to get it out. To undo that 2, we're going to divide by 2, divide by 2. So b equals 7. Now we need to check. Is it true? Is it true that, I need a new color, pink. Does 7 make this equation true? It's going to be a lot of steps to check it, but here we go. Let's plug it back in and check. So the square root of 7 times 7, because we're plugging 7 in for b, minus 4. Is that equal to, let's We don't know, so we'll ask, is it equal to 5 times 7 plus 10? Well, let's work it out and let's find out. 7 times 7 is 49 minus 4. Is that equal to 5 times 7 is 35 plus 10, the square root? Well, 49 minus 4 is 45. So is the square root of 45? Ooh, yuck. I don't know what the square root of 45 is. Yuck. Is that equal to the square root of 45? Yeah. Sweet. Cool. So it works. So B is equal to 7. Awesome. Now that's great, Miss Van Dyke. But when are we going to use this in real life? Okay. Let's say you have a clock. And the time T it takes for the pendulum. Do you know what a pendulum is? The pendulum is the swingy thingy on the clock. It's this guy right here, the thing that goes back and forth and back and forth. So it's like the tick-tocker on a tick-tock clock. Tick-tock, tick. That's what it does. Okay. So the time that it takes for a pendulum to complete a full swing is approximated by the equation T, which is the time it takes, equals 2 times the square root of L divided by 3.3, where L is the length of the pendulum in feet. Hey, our pendulum is already kind of orange, so say L is the length of the pendulum in feet. If the pendulum of a clock completes a full swing in 1 second, well, that makes sense, right? It goes back and forth every second. So that's the time it takes to complete a swing. How long must you make your pendulum? Well, let's find out. So we'll start by rewriting our equation. We have T equals 2 times the square root of L over 3.3. Nice. And we know that T stands for time, and our time is 1 second, so we can just substitute 1. Yay. Isn't that great? Okay. So we say 1, that kind of looks like a line, 1 equals this again. Yay! Except now let's look at, we're trying to find out what L is. We want to know, hey, what is the length of our pendulum? And what's happening to our L? Well, it's got a dividing by 3. It's in the square root wrapping paper. And it's got a 2 times bow. So we're going to need to undo the 2 times bow first. So we divide by 2 on both sides. That gives us that 1/2 equals the square root of L divided by 3.3. So the next thing that we can undo is the square root. How do we undo a square root? We undo a square root by squaring both sides. This is the same thing as 1 squared over 2 squared. And then these cancel out, so we get L over 3.3. Cool. Now I'm out of room, so I'm going to copy this step and go over here and keep working. 1 squared is 1. Oops, 1. 2 squared is 4. L divided by 3.3. And we're almost done. The only thing left is divided by 3.3, and we don't want L to divide by 3.3. So we're going to undo that by timesing by 3.3 on both sides. Oh dear. Because multiplying will undo a dividing. So that means that these guys cancel out. Bye. And then over here we get 3.3 times 1, which is just 3.3, divided by 4. And that's the length of our pendulum. That comes out to approximately 0.8 feet. So guys, that's a little clock. It's like a foot tall. It's a little baby. Take that. It's not a grandfather clock. It's a little grandbaby clock. So cute. All right. Now that's great, but sometimes we just need a little extra. Or maybe the problem is being extra. And you're like, dude, cool your jets. That's too much slang. So we have times where the problem, or rather the solution, is extra in math. We call it extraneous. Okay. An extraneous solution is one that doesn't make sense, one that is outside. That's what extra means. Extroverted means you get your attention from people outside of you, or extraterrestrial means someone that comes from outside of Earth. That is an alien. Okay, extra means outside. An extraneous solution is one that doesn't satisfy the original equation. It's outside of what's acceptable. When I say satisfy, I don't mean like make happy. I mean make true. So it doesn't make the equation true. So that's why we need to always check your answer. Okay, so let's see. Okay, so let's first solve each equation and then we'll check. So here we're trying to get C all by itself, but oh man, you guys, we've got this square root over here, and that's gross. So we're going to undo that. We're going to undo that by squaring both sides. Yay! What's nice about that is that we'll also get rid of our negative on this side, because negative C times negative C is C squared. Because negative times a negative times a negative is a positive. Cool. Okay. And then I get rid of the square root on the other side, so you get C plus 6. Cool? Oh, you guys. This problem is extra difficult. Okay, anyway. And then we're going to get everything to both sides, because we want it all on both sides, by subtracting C and subtracting 6 on both sides. So we get C squared minus C minus 6 equals 0. Now, if you've done factoring before, we haven't done factoring yet this year, so we'll go ahead and review it later on in this year. They'll tell you that will get, we can break this guy down into C minus 3 times C plus 2. If this step confuses you, don't worry about it. Okay. And what we end up doing here, because we'll go back, we'll talk more about lessons like this, is we split this up and we say, okay, well, C minus 3 equals 0 and C plus 2 equals 0. And then we can solve from there by adding 3 to both sides of this equation. So we get either C equals 3, or on this side, minus 2, C equals negative 2. So we actually have two answers, two solutions to this equation. Now let's see, is this true? Let's see for C. So we're going to plug it in and find out. So we'll plug into our original equation. I'm going to copy it right here and then move it, if that's okay with you guys. Negative C equals the square root of C plus 6. Yeah, that was the original problem. And then I bring this down here. I want to test. Is it true? If I plug C equals 3 in, will this still be true? Is it true that negative 3 equals the square root of 3 plus 6? Well, is negative 3 equal to the square root of 9? No, because you can have a negative. It needs to be positive, right? Because the square root of 9 is 3. Yuck. So we call this guy extraneous because this is not equal. And we say, nope, sorry, you're not real. We're not going to include you in our answer. Let's try again. Let's check on this side. Oh, I already used blue, didn't I? I'll do purple. So we say that C is negative 2. Let's check. Does that work? Well, negative 2, is it equal to the square root of negative 2 plus 6? Well, negative 2 is positive 2. And the square root of negative 2 plus 6 is 4. Is 2 the square root of 4? Yes. Yes, it is. Awesome. So we just have one solution. C equals negative 2. Now this guy over here. Let's try and solve him. Here we go. We've got our D box, and on our D box we've got some ×2 wrapping paper, we've got a square root wrapping paper, we've got 6. Okay, so first we need to get rid of the 6. So we're going to minus 6 from both sides. That gives us negative square root of 2D equals 4. And now we need to get rid of the negative. So we're going to multiply by -1 on both sides. And that will cancel out the negative on the left, giving us the square root of 2D equals -4. But guys, I have some bad news. Square roots can't be negative. This has no solution. We can just stop right there. We don't even need to check. Okay. Cool. Oh, okay. So remember that you need to check your solutions. That was messy. I'll redo it. Oh, that wasn't even an eraser. Check your solutions so that you know that they satisfy the equation, that they make sense, that they are not extra. You should always check your work anyway. It's a good idea. Okay, solve equations with radicals using squares. That's your big idea right here. Hope you have a wonderful day.